Hello, today we are going to talk about distributing points on the surface of an object and then replacing them by instances and aligning those instances to the normals of the base object. So we have the base object, which is the torus. Let's start by creating a new geometry node and add a point, distribute points on surface, on faces. So here you have all these points on top of the torus that you can change their density. And to replace these points by the cone, let's add an instance on point and place it over here. Everything has disappeared because we do not have an instance yet. So let's grab this cone here and place it inside the geometry nodes and apply it as an instance. So you can see that now all these cones are placed on the surface of the torus, but they are all aligned by the z-axis. If you did this on Blender 2.93, you would have them aligned by normals. And how do we do that? So we have to feed the normals from the torus to the points in order to generate the instances with that alignment. To do that, you have to pick the normals as an input, and we'll have to go and grab that attribute, the normal, from the mesh. For that, we use the transfer attribute node. The transfer attribute node originally came as a float, as an input, so change it to vector because the normal is a vector. The target from which we are going to capture those normals is the torus, so let's bring that into the target. And the normal is the attribute that we're going to be using. So we have the vector of the normal that we want to transfer to the points, but the rotation on the instances is described in degrees. So how do we translate this vector into degrees? For that, we need to add another node, which is in the utilities, and it's called align Euler to vector. It will align the rotation to the vector that we feed here. So let's pick this vector, feed it into the vector input. We are going to be aligning the z-axis, and grab this rotation and feed it into the instances. So now you can see that all these cones are aligned along the normals. It will be easier to see if we join the geometry of the torus to the output too. So let's go to add geometry, join geometry, get that torus into here. We'll grab the points into here and use everything as the output. So it's clearer now that everything is aligned to the normals. In order to, for example, to place the instances only on the vertexes, you cannot do that with the distribute points on faces. Let's see how you can do that too. You go to add and mesh and use mesh to points. So we'll be converting the torus to points only on its vertexes. In order to see that, let's just link this directly to the output. See, no, all the points are on the vertexes. We'll no longer be using the distribute points on faces. We'll be using instead the points that are on the vertexes. So let's link them here. And as you can see now, we have all these cones on top of the torus surface, but you can notice that the normals are not perfectly aligned. Why? Because when we are capturing the attribute, he has been picking it from the nearest face interpolated, not from the exact point of the vertex. We can do that by changing to nearest and capture the normal exactly at the point. Since the points of the mesh and the point cloud are exactly in the same place, you'll have exact normals. See, now it's perfect. If As another example, you'd want to place those instances at the center of the faces. You could pick here mesh to point on faces, but as you see, normals are not aligned again because he's picking them from the points instead of the faces. So you just have to go to the transfer attribute and pick faces instead of points. And now you have the perfect alignment to the normals of the faces. Well, I hope this will be helpful to you, and thank you, and see you on the next tutorial.